Hey all, welcome to Homeschool. Hope everybody are doing good. I have come up with these important questions on physics, chemistry and biology for class 10 students, especially those who are going to write Karnataka SSLC board examination for the year 2022. See, in this video, I'm going to talk about some of the chemistry important questions. And before that, let me give you the blueprint of chemistry chapters. Okay, the marks that is allotted for each chapter under chemistry. So altogether, chemistry, you will get it for 25 marks. Out of 80, 25 marks you have to attempt for chemistry questions. Okay. Under that, the first chapter, that is chemical reactions and equations. Okay, so this chapter carries about 5 marks, and second chapter, that is the most important chapter, acids, bases and salts. So this chapter carries about 6 marks, and coming to third one, metals and non-metals. So this chapter has got 5 marks. Then fourth chapter is carbon and its compounds. So this chapter has got a weightage of around 5 marks. And finally, the fifth one, periodic classification of element, has got 4 marks. Okay, so this is how 15, right? Then 20, 25. So altogether you have 25 marks for chemistry chapters. So in this video, I am going to give you some of the most expected questions from chemical reactions, equations and acids, bases and salts. So along with the question, I'll discuss the concept that is there around. Okay, so listen to a video till the end. Definitely you will get maximum benefit out of it. Okay, so let's go to the questions that they can ask from the chapter chemical reactions and equations. See guys, these are some of the top most important questions from chemical reactions and equations. So definitely you can expect a few questions among this, or at least the questions that is relating to these topics. Okay, so let us try to discuss the answers for these important questions. Clear? Look at the first question. Write one equation each for decomposition reaction where energy is supplied in the form of heat, light and electricity. So we all know these decomposition reactions are those reactions in which reactant is single, right? So you will have only one reactant, and this fellow will undergo decomposition, that means breaking, okay, in presence of some energy, either in the form of heat, light or electricity, and you will get so many products, right? So you will get many products, right? So such reactions are called decomposition. So we have 3 types of decomposition, right? So the decomposition where heat is used is called thermal decomposition. So thermal decomposition is what? Decomposition that is done with the help of heat is called thermal decomposition. So what is the famous example that you can write here? That is FeSO4 on heating. This fellow gets converted into Fe2O3 plus sulfur dioxide plus sulfur trioxide. So this is the example you can give, okay, for the decomposition reaction that is taking place under heating. So that is called as thermal decomposition. So you should definitely balance the equation, okay, and you should also be knowing about the color change. Individual questions can be asked on the color change also. Say, what is the color change that takes place here? See, usually FeSO4 is green in color, and this green color crystals gets converted into brown color crystals. Not only that, these are the 2 gases that comes outside, and they will have smell of sulfur. They will have smell of sulfur, right? Burning smell of sulfur, right? So this is one famous example that you can give for the decomposition reaction on heating. Okay, and decomposition reaction under electricity is called electrolysis. So for electrolysis, what example you can give is water. So water on passing electricity, okay, so water gets broken up into hydrogen and oxygen, and it's very important to know whether which product is obtained at what electrode. In electrolysis, we will have two electrodes, right? One is cathode, the other one is anode. So here, hydrogen is formed at cathode and oxygen is formed at anode. Okay, so where do you get the product? Which product is formed at which electrode? That question also can be asked from this particular topic. Okay, and coming to decomposition reaction with the help of light. Okay, so such decomposition reactions are called photochemical decomposition, right? So photochemical decomposition. What example you will write here? AgCl, which was white in color. Okay, so on exposure to sunlight, this AgCl gets converted into gray color Ag plus Cl2. Okay, so this is the equation you can give. And what is the importance of this equation? This equation or this chemical reaction is used in black and white photography. Black and white photography. Okay, so along with the answer, I told you various possible questions that can be asked on each and every reaction. Okay, so this is the answer you can write for this first question. What is that? Write one equation each for the decomposition reaction where energy is supplied in the form of heat, light and electricity. Okay, fine. So now let us go for the second question, which is also very important and it can be asked in a different ways. Okay, so let's read out the question first. What happens when iron is dipped in copper sulfate? So what will happen when iron dipped in copper sulfate? Definitely displacement reaction happens, right? So what is the answer you will write for the second question? You have to write the chemical equation. Guys, one thing you have to be very careful with chemistry questions is writing balanced equations. Okay, so whatever they ask, for that you should write balanced equation. Otherwise, marks will get cut. Okay, so in that case, you have to be very careful. So what is the chemical equation you will write here? Fe. So on dipping into copper sulfate solution, you will get FeSO4 plus copper. Okay, so that this blue color of copper sulfate gets converted into light green color of iron sulfate. Okay, and this copper is there now that gets deposited on iron rod. Okay, suppose this is an iron rod dipped in copper sulfate. What happens? Blue color changes to green and copper comes and deposits on iron. Okay, so what reaction is this? They'll ask you what type of chemical reaction is this? So you will have to write this is a displacement reaction. This is called displacement reaction. Okay, so displacement reactions are very important. Fine. And coming to third question. What are precipitation reactions? Give example. Okay. See guys, precipitation reactions are nothing but double displacement reactions. Yes or no? So they are double displacement reactions. Okay. So where the ions gets displaced with one another. Right? So in this double displacement reaction, insoluble substance is formed. Some insoluble substance is formed which is called as precipitate. That insoluble substance is called precipitate. Okay, so one very famous example you should never forget in this chapter is this example. Lead nitrate, that is PbNO3 twice, on combining with potassium iodide, you will get lead iodide plus KNO3, and this lead iodide is yellow colored PPT. Okay, so this is that one very famous example you should not forget, guys. Okay, so they'll ask you the question in a very different way. They may ask you what happens when lead nitrate is added to potassium iodide and what type of reaction is this. So what will happen? LOPPT, that is lead iodide, is formed. What type of reaction is this? It is nothing but double displacement reaction, or you can also write it as precipitation reaction. Okay, so this is the concept of the double displacement which you should not forget. See, question may not be asked this much direct, but I'm telling you the other way of asking question also here. Okay, so with respect to example question can be asked. This is added to this. What happens and what type of reaction is this? So you have to be very careful with such questions. Okay, fine. And coming to the next question, which is actually very famous, and this question had come in most of the question papers when we check previous year papers. Okay, is respiration exothermic? Give reason. You actually should give reason here. So I'm talking about the fourth question. Is respiration exothermic? Yes. Okay, yes, it is exothermic. Give reason. Because during respiration, heat or energy is liberated. Energy is liberated. Right? So that is why we say respiration is exothermic. What is the chemical reaction that you can write for respiration? C6H12O6 plus O2 will give you carbon dioxide plus water plus energy, right? So this is the chemical reaction you will write, where food undergoes oxidation to give carbon dioxide, water and energy. Since energy is nothing but a form of heat which is coming outside during reaction, so it is called exothermic reaction. Okay, and here one more question. Is photosynthesis exothermic or endothermic? What may be your answer? Photosynthesis. Is it exothermic or endothermic? Pause the video and you can post your answer in the comment section. Okay, fine. And actually, this photosynthesis is endothermic reaction, guys. So can you tell me why photosynthesis is endothermic? Because sunlight is used in photosynthesis, right? What is endothermic reaction? The reactions in which heat is required. With the help of heat, we perform a chemical reaction. Such reactions are called endothermic reaction, right? So what is the equation you will write for photosynthesis? Carbon dioxide, water, and we write here sunlight, right? In the presence of sunlight and chlorophyll, you will get C6H12O6 plus O2, right? So this is photosynthesis. So photosynthesis is endothermic. Why? Because energy is required. Energy is supplied here in the form of sunlight. Respiration is exothermic. Why? Because heat is liberated outside. Okay. So these are some important questions that they can ask you in the give reason format. Okay. Fine. And coming to the next question, what is corrosion? So it is such a simple concept. See, corrosion is what? Spoiling of metals. Okay. Spoiling of metals due to oxidation. Due to oxidation. When they get exposed to. When they get exposed to air or moisture is called corrosion. Okay, so example, So they may ask you examples also. So the best example for rusting is, best example for corrosion is rusting of iron. Rusting of iron. Okay, silver becoming black, copper becoming green. So all of them can also be an example for corrosion. Okay, so corrosion is what? Spoiling of metals due to oxidation when they get exposed to air or moisture is called corrosion. Okay, and how do you prevent corrosion? It is by painting we can prevent. Okay, so preventive methods are very rare. Okay, preventive methods, actually it is a topic of metals and non-metals which is deleted. Okay, so but here you try to understand the definition of corrosion. And coming to last important and very famous question from this chapter is, what is rancidity and how do you prevent it? Okay, so what is this rancidity? Definition is important, and the different ways of preventing rancidity is also important. So what is the definition of rancidity here? Change in smell of fats and oils due to oxidation is called rancidity. Okay, so very simple definition. If you can write this, you will get 1 mark. Okay, see, change in smell of fats and oils. Why the smell will change? It is because of the oxidation. When you expose fats and oils to air, you know, their taste and smell. Okay, you can also include one thing, change in smell and taste. Smell and taste of fats and oils due to corrosion. And how do you prevent it? You can prevent it by adding antioxidants. Okay, so what are the best example for antioxidant? It is nitrogen. Okay, so question can be asked like this also. Chips and biscuit packets are flushed with nitrogen gas. Why? It is because nitrogen is antioxidant which prevents rancidity, right? So this is how the questions can be asked in a different way also. Clear? So these are the most important and expected questions from this chapter. Not only this, you have another type of important question from this chapter is something like this. So they give an equation ZnO plus carbon giving you carbon monoxide plus zinc. Okay, so they'll ask you which is oxidized and reduced. These are very, very common type of questions from this chapter, guys. Okay, so how do you identify which is oxidized or which is reduced? Just look at this zinc oxide. This zinc oxide, how it is there in the product, it has converted into zinc. Before it was zinc oxide, now it is in the product side, it is there as just zinc. So what is the difference? Oxygen was here before, but here the oxygen is not there. Removal of oxygen took place, right? So what you will write? Zinc oxide underwent reduction. Okay, so what do you write here is zinc oxide is reduced, you write. When this fellow is reduced, the other reactant has to be oxidized. You no need to check again, okay, whether addition of oxygen took place or removal took place. So once you confirmed with one reactant and you confirmed that it got reduced, then the other reactant must have undergone oxidation only. Okay, so immediately you will write carbon is oxidized here. Carbon is oxidized. Okay, so this is how you will confirm the answers. Okay, suppose I'll take one more example here. Copper oxide is there. So I pass H2 gas. So here what happens? It gets converted into copper plus H2O. Can you tell me which is oxidized here? Okay, confirm with this. CuO got converted into Cu. That means removal of oxygen took place. Removal of oxygen means reduction, right? So that means copper oxide is reduced. Fine. If copper oxide is reduced, who has underwent oxidation? Definitely hydrogen. So what is your answer? H2 is oxidized. Okay. So these questions are very common and very famous, and definitely 1 mark point of view or MCQ point of view, one question surely come from this particular concept. Okay. Definitely one question may come on this aspect, guys. Careful. So any equation they'll give you and they'll ask you which is oxidized and which is reduced. So you have to talk this with respect to reactants only. You're not supposed to touch the product and write. Okay. So among the two reactants, if one is reduced, the other one will be oxidized only. Okay. So you will have to carefully check. You take one reactant and you see what it got converted in the product. Okay. You look at the change. Removal of oxygen, if you observe, it is reduction. Removal of hydrogen, if you have observed, it is oxidation. Okay, so this way carefully you should analyze and give the answers. Okay, so these are some of the most expected and important questions from the chapter Chemical Reactions and Equations. Okay, so from this you can definitely find few questions, guys. Okay, in this year final examination. And not only that, diagrams. Okay, so from this particular chapter you have this diagram, electrolysis of water. Okay, so this electrolysis of water is very important. So from this chapter, what is the diagram you have to concentrate? Electrolysis of water. Okay, so which is very important. If it is asked, it will be asked for 2 marks. Okay, so this is all about chemical reactions and equations. Now let us also talk about the chapter acids, bases and salts and its important questions. Okay, look at these questions from the chapter acids, bases and salts, guys. So from these questions, definitely any two you may find in the board examination. Okay, so the question may not be asked as it is, but relating to any one of the concept. Okay, so you will surely find a question. Coming to the first aspect, what gas is liberated when acids react with metals? Okay, so whenever acids react with metals, what do you get? You will get salt and hydrogen gas. So which gas is liberated? Hydrogen gas is liberated. And they may ask you, how do you test the presence of this hydrogen gas? So I'm adding one extended question here. How do you test this gas? How do you test the gas? Okay, so how do you test the hydrogen gas? When you keep a burning candle near to hydrogen gas, it burns with pop sound. It burns with pop sound. Okay, so the way you test the gases is also important in this chapter. Okay, so this is the first aspect of the chapter which you have to remember. And if one example is asked, what is the example you will write? You can write this. Zinc plus zinc is a metal. When you add to acid like H2SO4, you will get salt, that is ZnSO4 plus H2 gas. So this is one example that you can remember for this particular aspect. Okay, fine. And now this is all about that question number 1. Coming to question number 2, guys, this is the most important topic. Question can be asked in any ways. You should able to give answer whichever the way they ask. Okay, fine. Name the gas liberated when dilute HCl is added to sodium carbonate. Okay, so this is a metal carbonate. Whenever acid is added to metal carbonate or bicarbonate, which gas is removed? Which gas is liberated? Yes, it is carbon dioxide gas. You will get this carbon dioxide gas in the form of brisk effervescence. Try to remember the word brisk effervescence, right? So brisk effervescence in the sense what? A gas coming out in the form of bubbles. So that is carbon dioxide gas here. So how do you write the equation here? let me take HCl and it is reacting with sodium carbonate, right? So what do you get? Salt, water plus carbon dioxide gas. So which is the salt you will get here? NaCl plus H2O plus carbon dioxide gas. So this is the chemical reaction you have to write. Fine. And then how do you test this gas? How do you test this gas? Okay, it is by lime water test. Okay, how did you check? How did you tested the presence of H2? It is by keeping burning candle near it. When you keep the candle, it is burning with a pop sound. In the same way, you will test the carbon dioxide gas by lime water test. So what is that lime water test? Very, very important, guys. What is lime water test? When carbon dioxide is passed through lime water, your lime water turns milky. Lime water turns milky is called lime water test. How do you write the equation here? What do you mean by lime water? It is nothing but calcium hydroxide solution. And when you pass carbon dioxide to it, what will happen? You will get white milky. Okay, so milky PPT, calcium carbonate is formed. Okay, so along with the calcium carbonate, you will have water also. Okay, and now one more concept you must be knowing here. And to this calcium carbonate, this is white precipitate. This is what we call lime water. I'm just telling you some extension of this reaction. Okay, so to this fellow, I mean to the calcium carbonate water already there with you, whatever has formed, to that, when I pass excess carbon dioxide, this white milky PPT is there, no? That becomes colorless solution, which is nothing but calcium bicarbonate. Okay, so calcium bicarbonate is colorless, guys. Okay, calcium carbonate is white colored PPT. So to this white color PPT, in case if you pass excess in the sense more amount of carbon dioxide, this fellow gets converted into colorless calcium bicarbonate. Okay, so both equations you must know about this lime water test. Okay, so this is about your third question. Coming to answer for question number 4. See, there is a concept of dilution. So you must know what is this dilution and how acid is added to water or base is added to water. This is one of the very, very important concepts. See, first let me talk about the definition of dilution. So what is dilution? Process of adding water to acid or base is called dilution. Okay, and very, very important, it is always recommended to add acid to water, but not water to acid. Why? Okay, so this is one of the very, very famous question, guys. Why it is always recommended to add acid to water but not water to acid? It is because the dilution is exothermic. Okay, so lots of heat is produced. When you add water to acid. Okay, so whenever we take acid in a beaker and from top you are adding water, what happens is suddenly heat is produced, so the contents in the beaker may splash onto a face and face may get burnt. That is why first you should always take water in a beaker, then slowly you have to add acid with constant stirring. Okay, so what is the answer you will write? So why it is recommended to add acid to water? Because dilution is exothermic, heat is produced, contents in beaker, may splash and burn our face, okay, so that is why it is recommended to add acid to water. So this is one of the very famous concept. Okay, coming to the last question here that I have wrote on a board. What is alkali? Give example. Okay, so this is also very famous question. Many times you can see this question in the previous year's paper. Okay, so what is alkali? Soluble bases are called alkali. So examples are NaOH and KOH. So these two you can give it as an example, or you can also write base that is soluble in water. Okay, so let me write the definition this way. Base that is soluble in water is called alkali. Example NaOH and KOH. Okay, so these are few important questions from the chapter acids and bases. Still many more questions are there. Let us discuss them. Okay, so simple questions. First one, what are antacids? So these are also questions from acid bases chapter only, but different set. Those 5 are of one concept, and these are of the next concept. It is all about pH and importance of pH in everyday life. Okay, so what are antacids? Give example. Okay, so this is another question that you can expect. What are antacids? The bases. Antacids are nothing but certain bases used to treat acidity. Is called antacids. So what is the example you can give? Magnesium hydroxide can be an example. Okay, so this is one very famous question. And coming to the second question, what is acid rain? Okay, so when rainwater's pH is below 5.6, it is called as acid rain. If rainwater's pH is below 5.6, whose pH? Rainwater's. Okay, so if rainwater's pH is below 5.6, it is called acid rain. So this is second question. And coming to third question, which is very important. What is tooth decay? How do you prevent it? Okay, so this was the question asked even in the preparatory examination. So you have to focus. So what is tooth decay? If mouth pH is below 5.5, it leads to tooth decay. Okay, so actually when you eat a food, what happens is, when the food is stuck in between the tooth, bacteria gets developed, and this developed bacteria releases some acid. Okay, because they release some acid, pH of the mouth will become more acidic, that is below 5.5. Then what happens is, this acid is there, no, that will dissolve the tooth enamel. Okay, tooth enamel is made up of calcium phosphate. Tooth enamel is nothing but calcium phosphate. Okay, so this calcium phosphate slowly gets destroyed by whom? By the acid that is created in the mouth. Okay, so whenever this enamel is destroyed, it leads to tooth decay. So that is the actual concept of tooth decay. And how do you prevent this? You can prevent this by regular cleaning of mouth. Okay, regular washing of mouth with toothpaste that contains bases. Okay, so this is a very general question that you can expect. Okay, and not only this, which acid is present in what source? Say in tomato, which acid is there? So tomato has which acid? It is oxalic acid. Okay, so vinegar as which acid? It is acetic acid. Okay, so which acid is present in which vegetable or fruit, they'll ask you. So that is one very important concept. Okay, or nettle leaves. So you have something called nettle leaves, and you have ant sting. Okay, so which acid do they contain? It is methanoic acid. Very important. They contain methanoic acid. Okay, so these are some very common questions from this particular chapter. And coming to the other aspect of the chapter, that is about salt. Okay, actually salt is a deleted portion this year, but still in the preparatory examination they asked questions from salts. Model question paper questions are there from this salt category. So here I'll discuss some of the most expected questions that may come from salt category also. Okay, so the first one is NaOH. Okay, so the first salt NaOH, which is nothing but caustic soda. It can also be called as caustic soda. And what is important here is its preparation. Okay, so preparation of NaOH is called with a name chloralkali process. Chloralkali process. So they'll ask you what is chloralkali process. Okay, so what is the reaction you will write here? NaCl plus water. To this, when you pass electricity, you will get NaOH plus H2 plus Cl2. Not only that, they will ask you what product is formed at cathode and what product is formed at anode. So here H2 gas is formed at cathode and Cl2 gas is formed at anode. Okay, so this is also very important. And not only that, they will ask you uses of every product. So what are the uses of NaOH? NaOH is used as degreasing, it is used for degreasing metals. Okay, and this is also used in paper and soap industry. Okay, and coming to the uses of hydrogen. Hydrogen is used as fuel and hydrogen is used to prepare ammonia. And uses of chlorine. Okay, so chlorine is used to prepare bleaching powder, right? And one more use is it is used in swimming pools. It is used in swimming pools to kill the harmful microorganisms, right? So like this, at least 2 uses you should remember for each product. 2 uses of NaOH, 2 uses of H2 and 2 uses of Cl2. So this is all about NaOH that you should be knowing. Okay, and now coming to our second salt, that is bleaching powder. So questions may come on bleaching powder also. So what is bleaching powder? CaOCl2 is the formula of bleaching powder. So how do you prepare this? When chlorine is passed through calcium hydroxide, CaOCl2 plus H2O is formed. Okay, so bleaching powder and its uses. You should know its uses. So where is it used? It is used in, again, swimming pools you can use. Swimming pools. Okay, it is used to kill the harmful microorganisms. And second one is used to bleach cotton and linen. Okay, so used in textile industry, that is in cloth industry, because it has got a bleaching property. It helps to remove the unnecessary colors. Okay, so this is all about NaOH and bleaching powder. So now we will go for another 3 more salts. Okay, so what you should know is their preparation and uses. That's all, guys. Nothing much to think about the salt, only their preparation and uses. So coming to baking soda and their formulas. Formulas are also important. Baking soda in the sense sodium bicarbonate. Okay, so how do you prepare this? So preparation of baking soda is very simple. You will take raw material as NaCl. You will add to carbon dioxide, ammonia and water. Okay, so you get to form NaHCO3 plus ammonium chloride. So this is the preparation reaction of baking soda. And coming to its uses, it is used in bakeries. Okay, so this is very important, guys. Why this is used in bakeries is when you heat this, carbon dioxide gas will come making holes. Okay, so that you will get fluffy and soft cakes. To prepare fluffy and soft cakes, this baking soda is used in bakeries. Okay, so not only that, it is also used as antacids. Since it is basic, no, it is used to treat acidic problems, acidity related problems. Okay, so these are the two uses you can remember. And coming to the next one, washing soda. Washing soda. Okay, the formula is Na2CO3.10H2O is called washing soda, guys. Okay, sodium carbonate is called washing soda, and its uses. So uses are very important here. It is used to remove. It is used to remove permanent hardness of water. Permanent hardness of water. Okay, see, hard water is the water which you cannot use for drinking and washing cloth or washing utensils or whatever, because this water has got calcium and magnesium ions. To remove those harmful calcium and magnesium ions, washing soda is used. That is what the meaning of this point. Okay, so not only that, it can also be used in paper and soap industries. Okay, so used to manufacture soap, this is used. So this is all about baking soda and washing soda. And now coming to the last salt that we get to study is POP, Plaster of Paris. Formula is important. It is calcium sulfate dot half H2O. Calcium sulfate hemihydrate is called as POP. Okay, so how do you prepare this? By heating gypsum, guys. CaSO4.2H2O is called gypsum. Okay, so when you heat gypsum, no, water molecule will come and it gets converted into half H2O plus 1.5 H2O comes outside. Okay, so this is about plaster of Paris. And plaster of Paris is always stored in a moisture proof containers. Why? That is another famous question here. So why plaster of Paris should be stored in moisture proof container? Because when it gets exposed to air, it will absorb moisture and it will become hard gypsum. Gypsum is actually very hard. So when you expose it to air, what happens? The ulta reaction happens. That means plaster of Paris gets converted into gypsum, which is very hard. Okay, and coming to uses are very common, right? Plaster of Paris is used in construction business to make POPs, okay, ceilings, and it is used to make statues, used in the field of medicine as bandages, okay, to recover from fractures. Bandage purpose, this POP can be used. So this is all about some of the important aspects, the most expected questions from the chapter acid, bases and salts. So in this video we have covered two chapters, okay, chemical reactions, equations and acid, bases, salts. In the next part of chemistry series, I will come up with remaining three chapters. Okay, so each branch I made it into two parts: chemistry part 1, part 2, bio part 1, part 2 and physics part 1 and part 2. So if you can read these important questions, definitely as far as my knowledge concerned, you will get around 50 plus out of 80. Okay, so don't forget to watch the videos, guys. Take the maximum benefit out of the content. You have all the chapters also, very detailed explanation is there in the chapters. You can use the content that is there in our channel too. Okay, so thank you so much. Meet you all with the part 2 of chemistry. Thank you so much. Keep learning and all the best.